We're ready for the test on Unit 6. So let's solve these systems. The instructions say solve these by graphing, and you'll notice that on this page in particular it says no calculator allowed. So we do need to make sure that we do this completely by hand. There may be somewhere we need to estimate, but let's go ahead and do this problem. You'll notice that on number 1 they're both in slope-intercept form, so we're in great shape here. You can see that on this one, and I'm going to do the second one in blue, the slope is 4 on this one and the y-intercept is 5. I do want to take a quick second to look at this one. Everybody would recognize that the y-intercept is negative 4 on this one, but take a look at the way that this is written. This is written with a negative x over 2. We've mentioned that several times. That would actually be a 1 in front there. So the slope on this one would be negative 1/2. So let's go ahead and graph that one. This one crosses at negative 4, and then we're just going to be careful as we sketch this. So this has a slope of negative 1/2. So we're going to go down 1 for a rise and run 2. Down 1 and run 2. We're going to go up 1 and back 2. We're going to kind of change the direction of that right there. And then I'm going to go ahead and just draw a nice straight line, as straight as I possibly can. It would be a really good idea if you made sure that you extended it to both ends of the graph, and then used a straight edge, edge of a ruler, edge of a binder, something like that, just to make sure you're graphing really straight. On the next one, we're going to cross at 5, and the slope is 4. So that means we're going to rise 4 and run 1. So I'm already off the graph right here. I'll just put a dot up there. And then we need to rely on these others on the other side to make sure that we get this right. So instead of going up 4 and right 1, we're going to go down 4 and back 1. We're going to go down 4 and we're going to go back 1, and look at that. It lines up perfectly. Looks like this. So this is one of those nice ones where they happen to land right on top of each other, where that stair-step pattern for the slope on one matches up with the stair-step pattern of the slope on the other one. So I'm going to put a big dot right here, and that point, remember we answer this as an ordered pair, is back 2 from the origin and then down 3. So this one is negative 2 comma negative 3. So that right there is the answer. There's the work that I did, and there's the answer. We circle that answer, make sure everybody knows we know what we're doing here. So take a look at the first one. We're going to need to put that in slope-intercept form. So the first thing I'm going to do is I'm going to subtract 6x from both sides. So I'm going to go ahead and write down negative 4y over here, negative 6x minus 16. We're going to divide both sides by negative 4, meaning we're going to divide every term on both sides by negative 4. So this is going to give me a positive 3/2, and that's going to give me a positive 4. So I've done some work here, and I want to keep track of that that's the right answer. So I'm going to go ahead and put a dotted circle around that. I'm then going to change colors, and let's move this one over here. So this is going to be, we're going to add 3x here and add 3x here. So this is going to be 2y equals 3x plus 8, and then we'll divide every term on both sides by the 2, and we get y equals, this would be 3/2 x plus 4. So again, I'm going to put a dotted circle around that one right there to make sure that I get credit for at least doing that part right. Let's go ahead and graph the red one. This one crosses at 4, and the slope is 3/2, so we would rise 3 and run 2, so about right there. It's off the charts, but we're pretty close there. Then going the other way, down 3 and back 2, down 3 and back 2, and notice how those are lining up. That looks great. So I've got this red line right here, and again, it's important to extend it in both directions because you never know where these are going to cross. And then let's take a look at the blue one. This one crosses at 4. Hey, wait a minute, take a look at this. It crosses right there, and the slope is 3/2, so we would rise 3 and run 2. So this is exactly the same line. So do you remember what happens if the lines are right on top of each other? If we want to find the points where the point where the lines cross, this crosses in all of these points. So every single one of the points on one line would work in every single one of the points on the other line. So what that means is there are infinitely many solutions. Okay? All right, on to the next one. And this is the last one where we can't use a calculator, so let's make sure that we get this right. First thing I'd want to do on this one is I'd want to move that 3x to the other side. So I'm going to add 3x here and 3x here. So this is going to be 5y equals, this would be 3x minus 15. We're going to divide everything by positive 5. So we're going to have y equals, this would be 3/5 x minus 3. Okay, so we're going to put a dotted circle around that one right there. We are going to be using that again in just a second. And on this one, I'm going to move the 3x to the other side. We're going to do that by subtracting 3x, so we end up with this, y equals negative 3x plus 5. So not too bad at all as far as coming up with the equations that we're going to graph. This one crosses at negative 3, so crosses down here at negative 3 and has a slope of, let's see, 3/5. So we're going to rise 3 and run 5. Going the other way, down 3 and back 5. So it's going to look like this. Okay. I'm going to make that a little bit straighter. Got to go through that line right there. And again, if you need to grab a straight edge or edge of a folder or something, please do. This next one crosses at 5, so 5 would be right here. And it has a slope of negative 3. So we're going to go down 3 and run 1. Down 3 and run 1, down 3 and run 1. Now you remember, whenever we skip over those lines and they don't actually have a point that's generated by the slope of each one of them where they intersect, then we're going to, I need that a little bit straighter, then we're going to have to estimate what the answer is. Okay, so on this one, let's see, we're going to say that this is between 2 and 3 in the x direction. And it's a little bit above that point right there, so it's in between negative 1 and negative 2. So I'd say it's pretty close to 2. I'm going to say that that is about, and again, all you have to do is get close. I'm going to say that's about 2.2, and then, gosh, this looks like it's really close to negative 2. So I'm going to say like negative 1.8 or something like that. If you wanted to say negative 1.5 or negative 1.9, totally okay, that would be just fine. So I'm going to go ahead and circle that one and we're all set to go. Okay, on the next page, this is the page where you can use your calculator. Okay, so you may use a calculator, but we definitely want to make sure that we're sketching the graph on the axes, and make sure that you scale your axes and round answers to the nearest tenth if you need to. So let's take a look at number 4. On number 4, the first thing we're going to do is we're going to need to move this around. So I'm going to make that a little bit bigger, so I've got some space to work here. And let's see, we're going to add x. So I get 2y equals, this would be x plus 20. We're going to divide every term on both sides by 2, so we get y equals, I'm going to write that as 1/2 x plus 10. Do the same thing with the blue one, so we're going to add 3x, so add 3x, and we get negative 2y equals 3x minus 12. Divide everything by negative 2, each term on both sides, so we get y equals, this would be negative 3/2 x, and then this would be plus 6. So we're looking good so far. So let's go ahead and graph those. I'm going to draw a quick sketch on the calculator, and then we're going to make sure that we have the right answer, and then we'll sketch it on the paper. So I'll bring up the calculator here. You'll notice that I've got stuff from last time, so I'm just going to hit y equals, and we just start typing. So I'm going to do that little trick on this one where we just do x divided by 2. It saves me a little bit of time. Kind of think of this as x over 1, slide that x on the top there, so x over 2 plus 10. There's that first one, and then the next one is negative 3 divided by 2 times x, and then we're going to add 6. Okay, so we make sure we've got those typed in the right way, and then if I were to just hit the graph button, it's going to graph these, and this is going to look pretty awful because I didn't check the window first. So when you come in and grab a calculator from the tote, you want to make sure that you've either reset it, or make sure that you go from the y equals menu immediately to the window, or you can just hit zoom and say, you know what, I always want this to graph it in the standard window to start off with, so we're going to hit 6. So that's what that one looks like. And there's that one. So we happen to be able to see the intersection point. It's about right there. Let's go ahead and graph this, or sorry, have this solve this. So we're going to hit second trace, so second calculate, hit the 5, 1, 2, 3 enters, and it tells us the answer is negative 2, 9. So we're in good shape there. I'm going to come back over here, and we're going to keep that in mind as we go through here. Let's see, this one crosses at 10 and has a slope of positive 1/2, so that would be going up in this direction. down 1, back 2, down 1, back 2. So it's going to look something like this. So again, we're just drawing a sketch right here. This one crosses at 6, which is right here, and has a slope of -3/2. So down 3, run 2, down 3, run 2, up 3, back 2, and you'll notice that those are right on top of each other. So pretty darn good sketch right here. This is going to cross at the point, you can tell from here, -2, 9. We're going to circle that. I am going to take this and make a quick screenshot of this so that we can kind of see what's going on here. And I'm going to paste this in our document so that anybody looking at this would be able to tell, not only did we draw a pretty accurate sketch by hand, we also graphed this on the calculator and it came up with the intersection point right there. So let's run through and do this next one. Same approach here. So we're going to move the x to the other side. We're going to subtract 5x from both sides. So I get -3y over here, -5x minus 6. We're going to divide everything and continuing to simplify. We get a y over here, we get a 5/3 x, and then a +2. So we've got that one all set to go. And then we're going to do the other one. So we're going to subtract 7x from both sides. We get 8y, -7x, and then -16. Divide every term on both sides by the 8. So we're going to have y equals -7/8 x, and then -2. Okay, wait for that to come across there. And we're going to grab the calculator. Let's see what we've got here. And we're going to go to y equals. We're going to type those in there. So this is going to be 5 divided by 3, and put the x in there, +2. And then come down on the other one. This is going to be -7 divided by 8. And then we're going to put the x there. It's already got space for it, so we're in good shape. And then we're going to subtract 2. And we are going to hit, let's see, zoom 6, just as the standard window. We could have just hit graph. Let's see what happens here. And looks pretty good. Okay, now these are not, this does not look like a very nice point, but let's check and see. We're going to hit second, calculate. We're going to hit the 5. Enter, enter, enter. And ooh, that's kind of ugly. Okay, now it says round to the nearest tenth when appropriate. So we've got this number right here. So on the graph, we're going to come back here and let's draw a sketch of this. This one crosses at 2 and has a slope of 5/3. So we're going to go up 5 and over 3. Up 5 and over 3, it'd look about like that. Down 5 and over 3. So we're going to get a graph that looks something like this. Okay, so draw as straight a line as we possibly can. And again, the cool thing about this is because we've got the calculator as a bit of a backup here, we don't have to be quite as worried about what our graphs look like. So this is going to be down 7 and run 8. Holy cow, down 7 and run 8. So that's going to put us about right here. Up 7 and back 8 would put us about right there. And then again, we just draw as straight a line as we possibly can. And then we rely on the calculator to tell us what the answer is. So we're going to come back here. I'm going to grab a quick screenshot of this. We're going to paste it in here so that we can kind of rely on that. I'm going to shrink this down just a tad, and then we need to write down the answer. And it did say round to the nearest tenth, so this would be negative. This would be either 1.5 or 1.6. That's a 7, so we're going to round it to 1.6. So I'm going to put approximately -1.6 comma, and then the other one would be, let's see, 0.62. So that's either going to be 0.6 or 0.7. So we're going to say, because of that 2, we're going to say -0.6. And then we're all set to go there. Okay, we've got a nice advantage on this last one here. That one is all set to go in slope-intercept form. Let's take a look at the other one. I need to move that over, so I'm going to subtract 10x. So this is going to be -2y equals -10x plus 4. We're going to divide everything by -2. So we get y equals, this would be 5x and then -2. So that's what we're going to graph. We're going to graph the two of these. So we'll grab a calculator. We'll come back up here. We're going to change the y equals. Whoops, hit that y equals again. Let's see, I just cleared those off, so we're all set to go. So we're going to type in 5x plus 4, and we're going to type in the other one, which is 5x minus 2. And you may know what's going to happen on this. I'm going to go ahead and hit graph because we're already in the standard window. We've got that line, and then we've got this other line here. Notice that they have the same slope, but they have different y-intercept. One crosses at 4 and one crosses at 2. So if we try and do a calculate, if we try and do an intersection point, we say first curve, we say second curve, and we could take a guess. It says there's no sign change. Now your calculator uses a sophisticated thing where it checks for sign changes in between the difference of those. So that's, it doesn't give us an answer, it just says quit. So we're going to go back here and we're going to hit 1 and then we're going to hit graph. So that's what it looks like. And I'm going to go ahead and snap a shot of this. I'm going to go ahead and paste it in here, make it a little bit smaller, and then we're just going to make sure that our sketch looks a lot like this. So the red one is going to cross at 4 and has a slope of 5, up 5 over 1, down 5, back 1. So this one looks like that, really steep in that direction right there. And then the blue one crosses at -2, so here, and has the same slope. So that would be rise 5, run 1, rise 5, run 1. So it's going to look like this. Okay, so down 5 and back 1. So that's what we've got. Okay, so you can see that they never cross. So what we're going to write on this one is no solution. Okay. All right, let's shrink this back down so we can see what's going on here. And we've got 2 more problems. On these problems, they're story problems, so we're going to be solving a system of equations in context. It says define variables, write systems of equations, graph the system, and then state the solution to the following questions. So notice that we've got an x and a y here. And again, what we're going to look for is we're going to look for rates, because that's going to help us figure out what the x and the y are here. So 2 road crews are paving highways. Crew A has already paved 50 miles and is paving 3 more miles each day. So there's a rate right there. Okay, so I'm going to write rate there to remind us. And then in parentheses, I'm just going to put slope. And crew B has done 60 miles, but they're only paving 2 miles per day. Again, that's a rate. When will the 2 crews have paved the same amount of road, and how much road will be paved? So on this problem, I'm going to write off to the side, this is 3 miles per day. That's going to be the y, and that's going to be the x. So we've got miles in this direction. We've got days in the other direction. We're declaring those variables, so we're saying x represents days and y represents miles. So if we set up that first crew, the first crew has already done 50 miles and they're adding 3 miles each day. So the first crew would be 3 miles per day added to the 50 they already have. And again, I'm just writing that in slope-intercept form from the get-go. The second crew, they've done 60 miles, but they're adding 2 miles per day. So that's going to be 2x plus 60. All right. Now, we can use the calculator on these, but I'm just going to go ahead and do this and see if we can get the right answer without using the calculator, and then we'll kind of use the calculator to confirm. Notice the broken axis right here. The red one's going to cross at 50. So 50 is right here. That's probably why they started there. And then we're going to rise 3 and run 1. They're doing 3 miles in 1 day. So we're going to go up 3 miles to 53, right in between 52 and 54, and 1 day. 3 miles, 1 day. 3 miles, 1 day. So 56 to 59, 3 miles, 1 day, 3 miles. So we're kind of going, we're hitting nice convenient point here, halfway in between, nice convenient point here, halfway in between. So it's looking something like that. Okay, so now that pattern makes a nice straight line, so we feel good about that. Let's take a look at the next one and see what happens here. This one, they started out at 60 miles, and then they're doing 2 miles per day. So the rate is 2 miles per day. So 2 miles in 1 day, 2 miles in 1 day, 2 miles in 1 day. Now again, don't get confused with the boxes right here. We're not counting boxes, we're counting miles. So this is, each one of these boxes represents 2 miles. So from 60 to 62, from 0 to 1 day. Okay, up 2 over 1. 2 miles, 1 day, 2 miles, 1 day, 2 miles, 1 day. Boy, they are slowly catching up, and look at this. I think they run into each other right on the end of this. So that's what it looks like according to our sketch. Let's grab the calculator and have it do this. So we're going to get rid of that. And I'm going to slide this over. We're going to do y equals, and the first one is 3x plus 50, and the second one is 2x and then plus 60. Now, this is certainly not a standard window. If I did, just for the heck of it, I'm just going to hit graph. It's going to work in the corner here. That little worm is going through there. We're not going to be able to see anything because it's off our chart. So let's go ahead and set this up with the window. We're going to go from 0 to 10. So 0 to 10 in the x direction. X min is 0, x max, smallest x, biggest x. The scale is 1, so we're okay with that. And then notice the broken axis. We're really not going to see much down below here, so I'm going to go ahead and put down 50 as the minimum and 80 as the maximum. And let's do the y scale. The y scale would be every 2 units, so we'll go ahead and hit that, and we'll hit graph. Gosh, that looks pretty close, pretty good confirmation. So we're going to hit second calculate. We're going to hit 5, and we're going to see what this does for us. We're going to see if it tells us where it crosses. Crosses at 10, 80, which is what this would be. 10 days, they'd have 80 miles each. So again, I'm going to grab that. I'm going to paste it on here so everybody knows we kind of confirmed our answer right there. Okay, there's our answer, and then we're going to write it down. It says, when will the two have paved the same amount, and how much road will they have paved? So that will be in 10 days, both do 80 miles. They'll both be at 80 miles. Okay, so there's our answer to the problem. So we're going to take a look at this next one, and I'm hoping this looks kind of familiar. A farmer has 27 animals. Some of them are chickens and others are cows. Altogether, these animals have 84 legs. How many chickens and how many cows does the farmer have? Okay, so we've got, the question here is how many chickens and how many cows. So the first thing we're going to do is we're going to declare variables. So this is going to be chickens, and I'm going to put the number right there, and number of cows for y. And this short little sentence right here tells us something about the number of chickens and number of cows. He's got 27 animals, so if we take the number of chickens and add the number of cows, it's 27 animals altogether. And we did this one before. Knowing what type of animal it is, it tells us how many legs there are. So a chicken has 2 legs, so we're going to do 2 times the number of chickens. That's how many chicken legs we have. Then 4 times the number of cows. That's how many cow legs we have. And altogether we have 84. Kind of makes us feel a little good that it's an even number. It better be an even number, otherwise we've got some sort of animal that's got some issues, we'll say that. Okay, so let's take the red one and let's move that around. So this is going to be y equals, if I move that around, that's going to be y equals negative x plus 27. I'm going to make this so we can see it for sure. So this is going to be y equals negative x plus 27. Okay, so we're going to graph that one. And then the other one is going to be, if I move that around, I'm going to subtract 2x. So we get 4y, that's a negative 2x plus 84. Divide everything by 4, all the terms on both sides by 4. So this is going to be negative 1/2 x. And then if I covered up this 4 right here, 4 goes into 8 2 times. So into 80 it would go 20 times. And another, let's see, 4 goes into 4 once, so this would be 21. Okay, so we're going to graph those 2 equations. Okay, so I'm going to slide this down. I'm going to grab the calculator, and we're going to get rid of this. I don't want to save that. We're going to go to y equals. We're going to type these in. So this is going to be, let's see, negative x plus 27. And then the other one is going to be, I'm going to do that little trick again, negative x. I'm just going to slide that x on the top, and we're going to divide that by 2, and then we're going to add 21. Okay, make sure we've got everything in here. Negative slope on both of these. So we're going to set up the window. Let's go from 0 to, looks like 0 to 30. 0 to 30. Scaled every 5. Okay, and in the y direction, let's see, 0 to 30. Okay, 0 to 30, and scaled every 5. And we're going to go ahead and hit graph. So we've got a line that goes down from left to right, which is what we'd expect. And maybe we should go ahead and change the window so that the scale is 1 on each one of these. They're labeled every 5. But we actually put a tick mark every 1 unit. So let's go ahead and change that. Just good practice there, making them look the same. Again, this is a nice square graph on our paper. This is kind of stretched out a little bit. That's why the axes don't look quite the same. Let's go ahead and have the calculator find the answer. And let's see, we're going to do 5, first curve, second curve, guess, and it says 12, 15. So let's leave that for now, and let's come back here and let's see what happens if we do this. This one crosses at 27, and the slope is -1, so down 1 over 1. So it's going to go like this, okay? So I'm going to grab my line making tool, and I'm going to start right here, and I'm just going to go down that line so that it looks like this, okay? So not too bad. And then let's graph the other one. So this is y equals -1/2 x plus 21. So it crosses at 21, and the slope is -1/2. So we're going to go down 1 and we're going to run 2, down 1 and run 2, down 1 and run 2. So you might notice, let's see, right there they cross. So that little stair-step pattern for the slope on one matches with the stair-step pattern for the slope on the other. So I'm going to grab my line making tool. Going to make that line up as close as I possibly can, maybe adjust it a little bit, and it sure looks like they cross right there. Now even on our little sketch here, even with these points and everything's not perfect and stuff like that, let's take a look here. So this is over, let's see, that's 10, 12, and then up 15. So I think these cross at 12, 15. Now, one thing that we don't have on our graph or on the paper here is what each one of these represent. We didn't label the axes. Let's go ahead and do that. Remember, this is chickens and this is cows. So what this means is there are 12 chickens and 15 cows. Now let's go back to the calculator and let's make sure that that's what that gave us. It did give us 1215. So again, I'm just going to grab that, copy it, paste it over here, and that way everybody can know not only did we get this right by sketching it by hand, we also got it right when we sketched it on the calculator and it confirmed what the answer was. Okay, really good skills in this unit. Good luck practicing for the test. Make sure you do this a couple times and ask questions if you've got them.